Hello, this is a short tutorial about upper and lower triangular matrices and LU decomposition. So let's look at first the how Mathematica determines the upper and lower triangular matrices. So I have written down a matrix A in this form. So this matrix is a 3 by 3 matrix. Its rows are first row are 1, 2, 3. Second row is 5, 4, 1. Third row is 4, 2, 6. So just some random number I have chosen. So, and you can see that if you want to write a matrix in Mathematica, so first of all you have to enclose the rows into the curly brackets and then separate it by commas, and then you have to enclose the whole matrix into outer curly brackets, and then each element of the rows will be also separated by comma. So this is the standard format over here. So, and if you want to show them show the matrix into the matrix form, so you have to include this matrix form command outside of this definition of the matrix. And then I have assigned that matrix a name capital A with a single equal to sign. Okay, so now if I now execute this command, and then I can show you the result. So in the matrix form, the matrix will be here 1, 2, 3, 5, 4, 1 as desired. So it is a 3 by 3 matrix. Okay, so first of all, let's find the upper triangular matrix of A. Okay, so for this the Mathematica has the command upper triangularize, and then since I have already defined the matrix with the name A, so I will use this upper triangularize, and inside of the brackets I will put A over here. I will put A over here, and then as I will give it a name as B to distinguish it from A, and then matrix form. So let's see what thing we get. So if I execute it, so then I will get this. So you can see that this is the result. So, and in this result is the upper triangular matrix for this corresponding to this matrix A. And you can see that under the diagonal all the elements are 0. Okay, so this is the upper triangular matrix. However, we can also make some certain changes into that. For example, if I put with this A and then I add an additional number 1 over here, so then I execute it, and then let's see what happens. So in this case, if I have put 1 over here, so I can see that the upper triangular matrix has moved towards right. Okay, towards right, and then all the elements for the diagonal have also become 0. So that means only the known 0 elements are above the diagonal in this case. If I put something like 2 in this case, so then it will shift one more line above. Okay, so in this way we can just customize the upper triangular matrix. Even for example, if I put -1 over here, so yeah, so this non-zero elements will move down towards here. So in this way we can change the upper triangular matrix. So the default is with 0 or without any 0. So then this will be the default form for the triangular matrix. So if we don't, so in case of 0 we don't put it, we don't need to put it. So then in this case you will see that this is the upper triangular matrix. So same is true for the lower triangular matrix as well. Okay, so for the lower triangular matrix, what we can do is I can take this command. Yeah, I will show what is the purpose of this command later on. So let me add this here, and at the moment I just do like this. Okay, so I start from like this. So I say the lower triangular matrix has say LT, or even I can say it as L as well. Okay, so lower triangular matrix has L, and then I enclose this bracket and then I execute it, so it will be this. So the corresponding to that is the lower triangular matrix is 1 0, so all the elements above the diagonal will be 0, and then if I put -1 over here, and then if I put -1 over here, so then all the elements below will be 0. Okay, now remember that in the LU decomposition, LU factorization, we need a lower triangular matrix, but for that lower triangular matrix, all the elements on the diagonal should be 1. Okay, so how we can obtain in this type of thing? So for example, the normal situation is something like this. Yeah, it's like that. So we get this kind of it. So if, for example, if we get a lower triangular lower triangular matrix, and with all ones on the diagonal matrix, so we need to add to that matrix with -1 over here, and then 0 0 0 0 over here, and then we need to add an identity matrix into with that, and then we will get lower triangular matrix in that format. Okay, so so this we can obtain by this type of formulation. So if we need the identity matrix, so for the identity matrix, okay, identity matrix is this identity matrix. So for this we need the identity matrix. So for example, we can have set up the identity matrix of order 3 to whatever, and then we can put it into its matrix form. And then we get this identity matrix. So if you now you can see that if I add this identity matrix to this this one, then what we can do is we can get the lower triangular matrix in our desired form. So if we want to get that lower triangular matrix in our desired form, so we can call it as LT. Okay, and then we can use the lower triangularized A with -1, then identity matrix as 3, and then if I execute this command, okay, that means in this case I am adding these two matrices, lower triangularized A -1, which was previously this matrix, okay, and then the identity matrix is this matrix. So then I will get like this. So in this case I get the lower triangular matrix in this form where all the elements are 1 1 1. So same thing we can do with the upper triangular matrix as well. If we want for the upper triangular matrix all the diagonal elements as 1 1 1, so we can add we can modify it, and then we can obtain the upper triangular matrix with the diagonal elements as 1 1 1. Okay, so this was a small tutorial about how to do some manipulations with the upper and lower triangular matrices. So now let's go to the task of LU decomposition, or LU factorization. Okay, LU factorization. Okay, so when we talk about the LU factorization, so we need we have one matrix, and then we need to decompose into lower and upper triangular matrix, where the lower triangular matrix is the one with the diagonal, all diagonal elements are 1. So let's take one example, and then take this matrix A. Okay, so this matrix A is -3 1 2. This is a 3 by 3 matrix. So now in order to decompose into or factorize into lower and upper triangular matrix, Mathematica has a special command, LU decomposition. okay, and then its argument is the matrix which we want to decompose. However, this command results into three outputs. Okay, so we call these outputs as LU, P, and C. LU, P, and C. So, and then since there are three outputs, so we enclose them into the curly brackets as the list of items. So in this case, these three outputs, and I will explain what these outputs are. Okay, LU, P, and C, and LU decomposition, and A is this matrix. So let's execute this command, and then we get this. Okay, I did not put it into the matrix form over here, but I can put it into the matrix form in here. So we get this output from here. So in this output, these first three elements are is the LU matrix. Okay, it is the LU matrix. Okay, it is actually not the exact answer. Okay, it is not. We have to extract our desired answers from these three elements. So these three numbers, like these three numbers, pertain to the exact elements. And the last two outputs are related to the P and C. You can see that the first output is enclosed into the an outer curly bracket. This one, okay, this outer curly bracket. So this is one output which is pertaining to LU, and the last two outputs are P and C are related with this. So this is P and this is C. Okay, so we can very easily see that P is the P is actually for the sequence of the rows which was used. So in this case, the sequence of the rows which was used is 1, 2, 3, which is normal. Okay, if for example, if this sequence of the rows is like 1, 3, 2, which will mean that this LU decomposition command has interchanged the rows 3 and 2 and to obtain the answer, which is normally for our hand calculations. We say that we cannot interchange the rows. If you will interchange the rows, then the matrix will also change, and then we will not get the LU factorization for the original matrix. However, this LU decomposition command is very smart. Okay, it's very smart. It automatically determines that for some of the matrices we need to interchange the rows to get the LU decomposition. But in this case, our output shows that there is no need to interchange these rows. So that's why the sequence is normal, 1, 2, 3, like in an increasing order. Okay, so in this command there is no need to interchange the rows to get the LU decomposition. And the last output is the value corresponding to C, which is 0, which this value of 0 shows over here is that the LU decomposition which has been obtained is quite well. Okay, that means that it is actually C is the short name for short for the condition of the matrix. We will say if the value of C is 0 or very close to 0 or something like very low value, we will see that we will say that in a qualitative manner the matrix is very well conditioned. Okay, conditioned. So for obtaining the inverse of the matrix, or for obtaining the LU proper LU decomposition. So this matrix, that means, is very well conditioned for obtaining the LU decomposition. So this only shows that not in every case you will get this number as 0. For example, if for very large matrices, and when we are using some real numbers with some decimal places, etc., so we will not get this very well conditioned number. Okay, so this is just this just shows the quality of the matrix for the LU decomposition. Okay, I'm almost at the end of this video clip, so I will continue it in the next video clip.